This is section 5.3. We're going to be talking about hypothesis testing for a proportion. So some topics to take note on are we're going to review the null and alternative hypothesis and then connect it with decision and confidence interval. And we're going to talk about decision errors, type 1 and type 2. We're going to talk about significance level, which is often we use the Greek letter alpha. And then we're going to talk about p-values. And then we're going to talk about decisions and conclusions. So these are the things you should take notes on for this section. Okay, so going back to, do you remember we did this case study with gender discrimination from a study from the 1970s. And we found that p hat, which is the sample proportion, was 21/24 for males, so 0.88. And for females, it was 14/24, 0.58. And then we had possible explanations. We had a null hypothesis, which is that promotion and gender are independent, no gender discrimination, observed difference in proportions is simply due to chance. And then the alternative hypothesis was promotion and gender are dependent. There is gender discrimination, observed difference in proportions is not due to chance. So alternative hypothesis is that something's going on. And then we had a bunch of simulations. And since it seemed really unlikely to get results as different as the actual results, we rejected the null hypothesis. And so we can say there's significant evidence to show that there was gender discrimination in regards to that study in the 70s. Okay, so let's recap. What did we do? Number one, we set the hypothesis. Number two, we check assumptions and conditions. There's always like a box in your textbook for almost all the later sections. We talk about different scenarios. There's a box of what assumptions you need to check for this type of scenario. Then you got to calculate a test statistic. So a test statistic could be proportion. It could be for new categorical data, could be an average for numerical data. And then you calculate a p-value. And then given that p-value, you make a decision, and then you need to interpret it in context of the original research question. Okay? So we start with a null hypothesis, status quo. Then we also have an alternative hypothesis, which is the research question, kind of what you're testing for. And then we conduct a hypothesis test under the assumption, so we're assuming, this is key, we're assuming that the null hypothesis is true. And then we see the p-value tells us how strange are our results if the null hypothesis were true. Okay, so if the test results suggest that the data do not provide convincing evidence, we stick with the null hypothesis. So then we either So we'll formally introduce the hypothesis testing framework, an example. All right. Now let's do a example. Earlier, we calculated a 95% confidence interval for the proportion of American Facebook users who think Facebook categorizes their interests accurately as 64 to 67%. So based on this confidence interval, do the data support the hypothesis that a majority of American Facebook users think Facebook categorizes their interests accurately? So here's the thing that not all stats students get. When you're talking majority, think like whenever you hear the word majority, translate it into over 50%. So translate it to a number. The word majority, translate it. So like if you're going through and you're kind of like a homework problem or test problem, and you're kind of making sure you circle things, the word majority is a number. It means more than 50%. Okay. So then our null hypothesis is that p is equal to 0.5, so majority. Think And really, you could say it's like greater than equal to. We'll just say equal to. And then the alternative hypothesis is it's one-sided because we're talking about majority. Is that greater than 50%? So majority would be here, right? And then the alternative, the null hypothesis is that we just set it equal. We have to set it equal to something. So we set it equal to 0.5, but really it could be greater, less than or equal to 0.5. So the alternative hypothesis, more than 50% of American Facebook users think Facebook categorizes their interests accurately. All right, so if the null is not included in the interval, reject the null hypothesis. So this is a quick and dirty approach for hypothesis testing, but it doesn't tell us the likelihood of certain outcomes under the null hypothesis. So it doesn't give us a p-value, but we can still make a decision based on the confidence interval. All right, decision errors. So what we're doing is not flawless. So for instance, like remember how we have this analogy to the court system, where the court system, sometimes innocent people are wrongly convicted, sometimes guilty people go free. So we can make a wrong decision in statistical hypothesis tests. We can often, though, quantify how often we make errors in statistics. So there's two competing hypotheses, the null and alternative. In a hypothesis test, we make a decision about which might be true, but our choice might be incorrect. So we've got the truth and then our decision. So if we're in here or here, we are good. We did the right thing. But if the null hypothesis is true and we reject it, that's a type 1 error. Okay? So if the null hypothesis is true, is that like the person is innocent, but then we reject it, we throw them in jail. So then type 1 error is like throwing an innocent person in jail. And then type 2 error is that something is going on. The person is guilty, but we fail to reject the null hypothesis. So then the guilty person goes free. Okay. So we almost never know the truth. We're just trying to get at the truth through numbers. So when we're talking about error, we're talking about the truth that we don't often know versus what we have. Okay. Hypothesis test is a trial. So null hypothesis, defendant is innocent. Alternative hypothesis, defendant is guilty. So which type of error is being committed in the following circumstances? Declaring defendant innocent when they're actually guilty. All right, remember from like last slide. The answer is type 2 error. All right, and then the other one is going to be the opposite. It's type 1 error. So which type of error do you think is worse to make? And I'm going to quote someone named William Blackstone. I'm going to move myself up here. Better that 10 guilty persons escape than 1 innocent suffer. And so Blackstone, I mean, he got quoted a lot in the Federalist Papers and Constitution stuff. So yeah, good person. All right. So type 1 error rate. So as a general rule, we reject the null hypothesis when the p-value is less than 0.05. So that means we're using a significance level of 0.05. Okay, this means that for those cases where the null hypothesis is actually true, we do not want to incorrectly reject it more than 5% of those times. In other words, we're using a 5% significance level. There's about a 5% chance of making a type 1 error if the null hypothesis is true. Okay, so the probability of type 1 error if the null hypothesis is true is alpha. Okay, so this is why we prefer small values of alpha. We don't want type 1 errors. We don't want to, yeah. Okay. We don't want to like declare an innocent person guilty. So back to our scenario here. Same survey asked 850 respondents how comfortable they are with Facebook creating a list of categories for them. 41% of the respondents said they are comfortable. These data provide convincing evidence that the proportion of American Facebook users are comfortable with Facebook creating a list of interest categories for them is different than 50%. So remember from number 1, set the hypothesis. Parameter of interest is a proportion of all American Facebook users, not just our sample. Okay, so there may be two explanations why our sample is lower than 50. It could be different. The true population proportion could be different from 0.5, or the true population mean is 0.5, and the difference is just random variability. Okay, so that means we set up our null hypothesis is that true, so not p hat. P hat is the sample, p is the true one. P is 0.5, and the alternative is that p is not equal to 0.5. Okay, so that's the first step, which is setting up our hypothesis. Okay, which of the following is not a condition that needs to be met to proceed with the hypothesis test? So respondents in the sample should be independent of each other with respect to whether or not they feel comfortable with their interest in being categorized by Facebook. Sampling should have been done randomly. The sample size should be less than 10% of the population of all American Facebook users. There should be at least 30 respondents in the sample. There should be at least 10 expected successes and 10 expected failures. Okay, I want you to pause your video and pick the one, like one of these things is not like the others. One of them doesn't belong here. Okay, so pause your video, pick one, and then I'll give you the answer in a second. So I'm going to give you the answer in 3, 2, 1. So D does not belong. That is for numerical data, and we have categorical data. All right, that's why different situations have different assumptions and things you need to meet, conditions you need to meet. Okay, the test statistic. So in order to evaluate if the observed sample mean is unusual, we need to determine how many standard errors away the null hypothesis it is. So that's the test statistic. So we're using p hat is, so we're assuming the null hypothesis. So we're assuming that the p is really 0.5 and standard error is 0.5 times 0.5 over 850 square root. So we're going to compute z. So our z-score then is our sample proportion. So that's p hat minus 0.5, which is the p from the null hypothesis. And then over here is standard error, which is different in every situation. For the situation where you have one variable categorical data, it is this equation. Okay, so we compute z, and same proportion, it's 5.26 standard errors away. Okay, so that is that low? How do we know how low it is? All right, so we just use the table in the back of our book or software to calculate the probability of being that far away. Okay, so p-values. When we use this test statistic to calculate the p-value, the probability, so this is the definition of the p-value, the probability of observing data at least as favorable to the alternative hypothesis as our current data set, if the null hypothesis were true. Okay, that's what the p-value is. So if the p-value is low, lower than 0.05, then we say that it's very unlikely, and we reject the null hypothesis. And if the p-value is high, then it's likely enough, and we do not reject the null hypothesis. Okay, so the Facebook interest categories, p-value is probability of observing data at least as favorable to HA, which is as our current data set, 0.41, if the null hypothesis were true. So if p was actually 0.5. So we're talking the probability that p is less than 0.41 or greater than 0.51. Okay, so that's the probability that absolute value of z is greater than 5.26. Now, if you look in the table in the back of your book, 5.26 isn't even on there. It's really far away. So it's really small. Okay, so then make a decision. P-value is less than 0.0001. So if 50% of all American Facebook users are comfortable with Facebook creating these internet categories, there is less than 0.01 chance of observing a random sample of 850 American Facebook users, where 41% or fewer or 59% of higher feel comfortable with it. Okay, so this is really low probability. So it's likely to happen. It's not likely to happen by chance. So since the p-value is low, lower than 5%, we reject the null hypothesis. So that's our decision. So we conclude the data provide convincing evidence. So that's the sort of thing, like these words are important. The data provide convincing evidence that the proportion of American Facebook users who are comfortable with Facebook creating a list of interest categories for them is different than 50%. The difference between the null value and observed sample portion of 0.41 is not due to chance or sampling variability. Okay, that's how we conclude something like this. All right, what about choosing a significance level? You don't have to use 0.05. So it depends on your application. So you want to choose a level that's smaller or larger depending on the consequences. So if type 1 error is dangerous or costly, you choose a small alpha, so like 0.01. Say you want to be like 99% confident. So you, in that case, we're choosing a smaller alpha, which means we're less likely to think something's going on if nothing's going on. Okay, if type 2 error is more dangerous or more costly, then pick a bigger alpha. Like the biggest you should go is maybe 0.1. So at that point, you're dangerous. You're in super danger of a type 1 error, anything higher than 0.1. Because think about it, every 1 out of 10 times you'll have a type 1 error when the null hypothesis is true. All right. Quick little thing before we, as we wrap up this section, 1 versus 2-sided hypothesis test. So in a 2-sided hypothesis test, so we're interested if P is above or below the null value. And in a 1-sided hypothesis test, we're only interested in P differing from the null value in one direction. So either greater than or less than. We're only interested in one direction. So if there's only one value in detecting population parameters less than, okay, if there's only one value in detecting population parameters greater, so then it could be P is less than P naught, P is greater than P naught. P0 is often the, P is the true proportion. P0 is the one we use for the null hypothesis. So 2-sided tests are often more appropriate because we can have bias that, like, we might be biased to think that it would only go off one direction, and we could have, it could actually go off in the opposite direction. So a 2-sided test is always safer unless you're doing a question like majority, minority, something like that. Okay. All right. That completes section 5.3.